So in this question, we want to collecting the definitions of properties of some stochastic process. So the first one is wide-sense stationary processes. So the wide-sense stationary processes only uses mean and autocorrelations. So in practice, they are much easier to get than second-order density. Based on the mean and the autocorrelation function, we can do many things already. Like we can do state estimation, parameter estimation, and prediction in mean square sense. So the second is the independent increment process. So the definition of those process I have already written in the paper, so I just talk the idea that I think of them. So for the independent increment process, we see that the Poisson process, random walk, and the Wiener process are all the independent increment process. So it seems that the independent increment property is somehow related to Markov process. So for the Markov process, we can see that the Poisson process and the Poisson impulses and semi-random telegraph and random telegraph, random walk, and the Wiener process are all the Markov process. So it's important to know what is Markov process. So for the Markov process, the future result is not affected by the past result. And the fourth one is the normal processes, also call it the Gaussian processes. So the statistics of the normal processes is completely determined in the term of its mean and autocorrelation. So in general, the mean is the function of t, and the fifth is the strict sense stationary process. So the strict sense stationary process requires that the capital X of xe to xn t1 to tn equals to fx x1 to xn and t1 plus epsilon and t2 plus epsilon to tn plus epsilon are equal. So which is not usual. So it's kind of rare to get a strict sense stationary process. So the sixth one is the white noise. So for the white noise is a part of Wiener process. So if for the Wiener process, if we wish to discuss its derivative, like Vt equals to dwt over dt, we would have the expected value of Vt will equals to the derivative d of expected value of Wt over dt equals 0. And the autocorrelation will equals to the alpha times delta and t1 minus t2. So the Wiener process does have derivative. So when we want to do some further discussion, instead of like Vt dt, we use dwt, and which where Wt is continuous with probability 1. And the seventh one is the mean ergodic process. So the algebraic process is that we have the limit t goes to infinity 1 over 2t times the integral minus t to t xt dt will equals to the expected value of xt in mean square sense. So for the term in mean square sense is one kind of consistence. So there are some others like improbability and something else. And the final one is the martingale, which is not that useful, which is not quite